Hi guys, today we'll be going through gradients, tangents and normals, and this is for the A-level maths course, for the AS level maths course. Okay, so say I were to give you the question, find the equation of the tangent to the curve x cubed, add 6x squared, add 3x, add 5 when x is equal to 3. What would be the first step? So if you've watched my previous videos, you'll remember the power rule for differentiation, and essentially we're going to use the power rule to differentiate this equation here. So f prime of x is equal to 3x, because you bring the power down, to the power of 3 take away 1, add 6 times 2, because you bring the power down, x to the power of 2 take away 1, add, here the power is just 1, so it's just 3 times 1, which is 3, x to the power of 1 take away 1, and then the constant just becomes 0. And we can simplify this to make it 3x squared, add 12, x to the power of 1, add 3x to the 0, and as we know, anything to the power of 0 is just 1, therefore this simplifies down to just 3. And now that we have our gradient function, we know that if we just substitute in our x value, which is in this case 3, we will find the gradient of the tangent to the curve at the point 3. And this evaluates down to 66. Now, if you use y minus y1 is equal to mx minus x1, you can use this equation to find out the equation of the straight line or the tangent to the curve at this point. So we know our gradient is 66. To use this equation, we also need one coordinate, so an x and a y value. We only have an x value, so x is 3. Therefore, if we just substitute 3 into our initial equation, so that's 3 cubed, add 6, 3 squared, add 3 times 3, add 5, we get, this is just 95. Now we have our coordinate, 395, and we have our gradient, 66. Now all we do is substitute this into our original expression, y minus y1 is mx minus x1. Now all we need to do is substitute in our coordinates and our gradient, so y take away y1, which is 95, is equals to m, which is 66, which we figured out when we differentiated this and put in 3. X take away x1, and x1 is 3, and this was given to us in the question. Now, all we do is rearrange. Which is 66x, take away 198. Therefore, y is equal to 66x, take away 103. And this is the equation of a tangent to the curve at the point where x is equal to 3. Now, if I were to say find the equation of, not the tangent, but of the normal to the curve x cubed add 6x squared add 3x add 5, how would we do this? So from our previous question, we know that when x is 3, our y coordinate is 95. And in our previous question, we also differentiated this expression. We found dy dx to be 3x squared, add 12x, add 3. Now, the normal is essentially a line which is perpendicular to the tangent. So if you had a curve, and this is your tangent, this here would be your normal at a right angle to that tangent. So when we put in our point where x is 3, we find the gradient of the tangent at x is 3 to be equal to 66, and this is exactly what we did in the previous example. Now, when you differentiate and you put a value into your gradient function, what comes out is always the gradient of a tangent to the point. Now, because we know that the normal is perpendicular to the tangent, we know that the gradient of the normal must be the negative reciprocal of the gradient of the tangent. Therefore, it would be negative 1 over 66. Now, we have the gradient and we have a point for the line on that curve. So, what we can do now is, let's write out our equation. Y minus y1 is equal to m bracket x minus x1. Substitute in our value, so y take away 95 is equal to m, which is minus 1 over 66, as that's a negative reciprocal of our value from here. Multiplied by x, take away x1, and x is 3. Now, we would multiply out the 66 to make things easier for ourselves, as it's much easier to use whole integers than it is for us to be using fractions. Now we just expand this out and rearrange. Add 3. Now 66y is equal to negative x, add 6,273, and y is equal to 6,273 take away x all over 66. Okay, to summarize what we just learnt. When you want to find the equation of a line at a given point, you use the equation y minus y1 is equal to m x minus x1, where m is the gradient and x1 and y1 are 2 points on the line. Now, when you differentiate an expression, so f prime of x, this will always give you the gradient of the tangent at x. Now, for the normal is essentially a line which is perpendicular to the tangent. Therefore, negative 1 over f prime of x, which is just a negative reciprocal, this is equal to the gradient of the normal. And then you can use these gradients and then a point in the curve, put it into this equation, and then find the equation of a tangent or normal to a curve at a given point. And this is a very, very common exam question. Alright guys, thanks for watching. I'd really appreciate it if you subscribed, left a like, and if you want me to go over something specific, just please leave it in the comment section down below, and good luck. Thank you.